Today we're going to show you the proper wheel maintenance for the Ford F550 Super Duty. So let's get started. The first thing you're going to want to do is safely chock the wheels. Next, you'll want to make sure the vehicle is in park and that the parking brake is set. And make sure you use jack stands for safety. Hey, good morning, Dave.
Good morning, Dean.
Glad you could come help us out here.
Yep.
Today we're going to learn about wheel removal and stud removal on an F550 to do it the way engineering would like it done. I see that you already got the truck prepped. Dave, one of the issues that we're having is a lot of people don't understand how this wheel functions, and a lot of people think that the hub carries the load. A lot of people think that the studs carry the load. The studs don't carry the load. Their function is to do clamp load, and the hub is only there to center the wheel. How would you check to make sure that this wheel was put on correctly? How would you know if anybody had touched this truck prior?
You'd have to do torque on the lug nuts and find out where they're torqued at.
That's correct. And one of our issues is that there's a couple of reasons why lug nuts get over torqued. Sometimes people will come in with a 1,000-pound impact and they'll just crank on them, and those are people that don't know about this particular system and style of technology. And what we want to do is today show you how wheel lug nuts get over torqued or under torqued, and understand clamp load versus torque, and there's a big difference. Hey Dave, shall we get started with our torque study?
Well, we need to have our safety glasses on first.
Good thinking. Hey Dave, today we're going to talk about the correct servicing procedure for the F550. One of the things we're going to learn about today is that this particular hub surface does not carry the load of the vehicle. Each one of these studs, when torqued to 165 foot-pounds, gives you 21,000 pounds of clamp load. And multiply that 21,000 pounds by 8 different times, that's a lot of clamp load. So today we're going to look at cleaning, removal, correct torquing procedure, where to find the correct air pressure for the tire. That's pretty much going to be it for the morning.
Well, that's good. I'd like to be walked through it.
Very good. Dave, one of the things that we want to check today is how do you know that this particular stud is got its integrity?
Well, you don't until you do a torque study on it.
That's right. And this torque study is going to be done in a tightening manner with a dial indicated torque wrench. That is the most accurate way to tell what it's torqued to. And the correct torque is 165 foot-pounds on this fastener, and at 165 foot-pounds you get a clamp load of between 21,000 pounds of clamp load on each one of those studs. That's a lot of clamping load. Now what we're going to do is you're going to check these studs to see what they're torqued to. Now Ford Motor Company says that this particular fastener should not be torqued over 230 foot-pounds. If you're 230 and above, the stud needs to be replaced. The reason for this is there's a couple of reasons. If you had a 3/4 inch impact and you drove this home and over tightened it and you stretched this stud beyond its strength limits, it didn't break, but it's half fractured. And it didn't mean that you did it, but the guy before you could have done that. And what you're checking right now is to make sure that this stud hasn't been over its capability. Shall we give it a try?
Sure. Well, that was 165.
Did it move?
Nope.
Okay, keep going. Now one of the things that we'd like to talk about, Dave, is when you do put an extension on the back to do a dual wheel, there's no way you'll get the torque wrench in there without one. That particular extension is a hardened one.
Well, it just torqued over 240.
Then we're going to replace those studs today.
Okay, well, let's do it.
All right.
So now let's go to the lab and understand torque versus clamp.
Hi, we're here at the Fastener Lab today, and I'd like to introduce you to Jerry. He's going to be our technician today, leading us through some fastener testing.
Yeah, Dale, what we'd like to do today is take fasteners and do some testing. We take some brand new fasteners for the F550 truck, some corroded fasteners off a truck with approximately 50,000 miles in the rust belt, and also take the rusted parts and clean them through the Ford procedure and then retest them to show the increase in clamp load. To do this test is relatively simple. We're going to do this with a torque tension machine that will read clamp load at the given 165 pounds torque that we put on all wheel fasteners on your F550 trucks. And this will clearly show us the change from new to used to repaired fasteners.
For me, that was very eye-opening when we saw the computer readout when the torque went on the nut to how much squish was getting on the load cell and how much is really holding the wheel on. It was very eye-opening.
And it's a very simple test to do, and it's certainly something that will open everyone else's eyes as to what's going on out in the field.
Excellent. Let's go do it.
All right, we're ready. Dean, we're here now at the torque tension machine in the lab, and what we have here is an actual wheel center from an F550. We have a load cell that's put in the joint to represent the hub on the axle, but it measures the load, the clamp load that's going into the joint. We have the nut and stud in here that are new components, and what this does is we're going to drive this down with a DC nut runner that has a transducer in it that measures the torque as we put it down. And the computer is going to record that torque, and it's also going to record through this load cell, it's going to record the clamping force that we're putting on this wheel to hold it in place. And we're going to do this experiment, again, like I mentioned earlier, with brand new fasteners that you would see in the Ford plant. And we're going to do it with fasteners off a vehicle that had approximately 50,000 miles in the rust belt. And also we're going to do it with fasteners that have been corroded and then repaired to show the increase in clamp after the Ford repair procedure. All right, we're ready now to do the first test with the brand new fasteners. That would be the fasteners exactly the way they come into the Ford production plant. As you can see, now that we've run it to 165 foot-pounds, we're actually coming up with tension of 22,000 pounds. This is a good result, and there are some variables in the joint that allows you plus and minus a little bit from 21,000 pounds. This time we're going to torque the same fasteners, only these are used, and they have approximately 50,000 miles in the rust belt on them, and they have grit and grime on them beside rust to show what the relationship of the clamp is when the fasteners are in this state. As you can see, we took it to 169 foot-pounds of torque, and the tension this time is only 7,700 pounds. So we've lost approximately 60% of the original clamp from the new fasteners. Our third and final test is the test we're going to run with the fasteners that were corroded and have now been cleaned up with a drop of oil put on, wiped on the threads, and also between the nut and washer. We're going to run this test again to see how much the improvement is on the clamp force. As you can see, after we cleaned up the fasteners and put a light coat of oil on, per the procedure, we're at 165 foot-pounds of torque, and we've gone back to 22,500 pounds of clamp. So a little maintenance goes a long way in holding the wheels on the vehicle. We have taken and put the 3 tests that we just run on a graph to make this visually easy for you to understand. And what we have across the bottom is the torque, and what we have up the side over here is the tension or the clamp load. When we ran our first part, the brand new part, the torque took it up to 165 pounds and our tension was at 22,000 pounds. When we ran the corroded part, the tension, we ran the torque up to the same level, 165 foot-pounds, but the clamp load is only approximately 1/3 of what it was as a new component. After we cleaned off the corrosion and grit and ran it again, the third test ran up to the same 165 foot-pounds, and you can see that they were very close in clamp load to the original part. So this is where we want to be to hold the wheels on a truck, not down here with dirty, corroded fasteners.
So now, let's continue with our wheel maintenance procedure.
So what's the best way to take these out?
You'll use this rotunda tool. They were nice enough to loan it to us. The part number is 211S063. It comes as part of a 3-piece set. And you can contact them at 1-800-ROTUNDA, R-O-T-U-N-D-A, at 768-8632 to get that tool.
Okay, I got the studs off. Now, what's next?
Good deal, Dave. Thank you. Hey, Dave, I'd like to introduce you to a friend of mine. His name's Dale.
Hey, Dale.
He'll be doing the wheel end of this training.
Very good.
What we'd like to do when we look at a wheel, as it's pulled off of the truck, we want to look carefully at the mounting surface of the wheel, inspect the bolt hole areas and the hand hole areas. We're going to look for cracks, any cracks that may appear in bolt holes. Look for any cracking or other out of service condition or damage. Some of these wheels we've seen hammer damage where people have tried to remove them from the hub. We're going to check the surface of the wheel for flatness. We're also going to look at the back side of the wheel where it's been against the brake drum, make sure it's got good contact against the brake drum. We'll inspect it for excessive corrosion, and then we'll perform a cleaning operation on the wheel. This wheel again is in quite good condition, but I've got some pictures I'll show you of out of service conditions where wheels should be removed from service.
Very good.
Here are some examples of wheels that have excessive corrosion. These wheels should be taken out of service.
Okay, Dave, to start cleaning and inspecting this wheel is in excellent condition, and on this surface, there's really nothing more you need to do, just wipe it off to put it back on the truck. However, on the back side, we do have some rust and corrosion. We're going to demonstrate to you how you would go about in cleaning that rust and corrosion off. This is in still good condition, and you'd use the same procedure on more severely corroded wheels until you got the corrosion off. So we'll lay the wheel down and then we'll go about cleaning it. Ready? Dave, it is always a good idea to wear safety glasses and a dust mask as you're wearing when you do this cleaning, but we'll use the die grinder and go ahead and just clean up all the rust and corrosion off the back surfaces. It's also an alternative to use a Scotch-Brite scuffing pad like this. It also works very well on more severely corroded wheels. So just go ahead and clean up the rust and corrosion.
Okay, why don't you step back because you don't have a mask on, and I'll raise some dust.
Okay, Dave, now that we've got all the rust and corrosion removed from the wheel, we want to wipe off any loose particles that are still laying on the wheel in preparation for painting. You can use a fast-drying acrylic enamel, and we'll spray this entire surface you've just cleaned up. Want to make sure that you do not get excessive paint on the mounting surface of the wheel. You don't want any runs on it, and the paint thickness should not exceed 3.5 mils. Dave, now we're going to inspect the wheel for flatness. It's an important part of the inspection procedure because we want to make sure this wheel hasn't been damaged by improper installation or removal procedures. To do that, you simply lay a straight edge across the face of the wheel and use a 15 thousandths feeler gauge and check the wheel for flatness. If the 15 thousandths feeler gauge does not go in, the wheel is acceptable.
Okay, very good.
Okay, Dave, after we have inspected the wheel thoroughly, we've checked it for flatness, we've cleaned loose corrosion off of it, we know that there are no cracks in the bolt holes or the hand holes. We want to make sure that the tire is inflated to the proper pressure for reinstalling it on the vehicle. Both the wheel and the tire have maximum load and inflation pressures that are stamped on the wheel and then molded into the sidewall of the tire. However, to get the recommended inflation pressure for this vehicle, it's necessary to go to the door jamb of the truck and look at the manufacturer's recommended pressure, which Ford provides to you. Dave, to find a recommended pressure for this truck, you look at the door certification label, and it shows the pressure of 75 psi for the front and 95 psi for the rear on this truck.
Very good.
Okay, Dave, now that we've checked the door jamb of the truck and we know we should have 95 psi on the tire, let's check the tire pressure and see what we've got.
Okay. It says 95.
Okay. Dave, the final thing we want to do with this wheel before we reinstall it on the vehicle is to apply a thin film of an anti-corrosive lubricant on the hub bore of the wheel. This will prevent this from sticking to the hub and galling the hub during installation, and it'll prevent that difficult situation of the wheel sticking on the hub as you try to remove it on a future date. Okay, Dave, now that we've checked this wheel, we'd want to proceed with all other wheels on the truck and inspect them in the same manner.
Very good.
All right, Dave, now what we're going to do is we're going to go in and clean the hub surface, take any rusting or scaling off so that we have a nice clean flat surface so that we have no lubricants or anything on there to cause any slipping action. So what we're going to do is we're going to take our die grinder and this rubber tool, and we're going to go in there and clean the surface. Remember to put our safety glasses on and have at it. Put your dust mask on so you don't breathe any gremlins. There you go.
Very good.
Hey Dave, what we're going to do now is clean up the hub pilot surface on this portion of the wheel, and we're going to clean this hub section here to remove all scale and rust.
All right, well, stand back.
Very good. Dave, what you want to do now is take the wire brush and come into the back of the hub surface and wire brush it off so that any of the garbage around the hole where the head of the stud sits is clean, so that you get a flush surface, no grit or grime in there. So take this and clean them up and we'll go from there. Very good. Hey Dave, what we're going to do now is we're going to take some brake clean and we're going to clean off any residual stuff, oil residue, or a lot of times technicians have put anti-seize on the back of it. That's a no-no, and we want to make sure that the bore is clean and free of debris. So we're going to squirt it off with this brake clean, and we're going to use the air blower, and we're going to blow it off and dry it up.
Very good. Air gun, here it comes.
That's it. Blow it dry. Watch your eyes. Okay, good deal. All right, Dave, what we're going to do now is that hub surface is clean. There's no debris in it. We're confident there's no oil on that hub surface. What we're going to do is install this stud now. And as you're pushing it through the back of the hub surface, there are serrations here. You see these?
Yep.
What you want to do is kind of push it through and wiggle it so that these serrations start into the serrations that were originally in the hub surface. Then you can tap this twice with a hammer lightly just to get them slightly engaged. And then we're going to take a stack of washers and the nut, and we're going to pull it through with an old nut, torquing this. Now I'll let you use impact to suck this up so that this is coming up to the back of the hub. As you pull it on, it's going to go like this. As you get about a 1/16 of an inch from the end, you're going to stop with the impact. And the reason why is you can hurt the stud putting in a brand new stud. Let's say that you only have a 3/4 inch impact and it's a 1,000-pound, foot-pound type of a tool. And you could hurt this stud even before you ever put a wheel on the car, so you don't want to stress it. So we're going to have you go with a clicker torquer wrench, and you're going to take the torque wrench that's set at 145 foot-pounds, and the last 1/16 of an inch, you're going to pull that the rest of the way with this nut and seat this. Now, 145 foot-pounds gives you approximately 9,000 pounds of clamp. The shop manual tells you to pull that hub off and take it to a press. We know that's not real world when you're stuck out in the field. So take your torque wrench set at 145. It'll be equivalent to 9,000 pounds of clamp load. It'll suck this stud in. Click at 145 and stop. Then you can take impact, back the nut off, and then look at the back with a light to make sure that this edge here is seated up against the hub.
Okay, very good.
All right. Dave, this coating on this stud and nut is a phosphate and oil coating. On a new stud and nut, you would not have to add oil to it to do a torque and bring up the clamp load correctly. So before we start here, this is an old nut on a new stud. Put a drop of oil between this washer and this nut just to help us get the correct clamp load. Very good. Now, we'll let you pull that on with the impact till the back of this just about seats on the hub surface, and then stop.
Okay.
Dave, what we're going to do now is seat this stud correctly at the right tension to the back of this without overstressing the stud. And what we're going to use is a torque wrench at 145 foot-pounds. At 145 foot-pounds, when you pull that stud on, it equates to 9,000 pounds of clamp. And that's more than enough pressure to suck that in all the way and seat it good.
All right.
Excellent. Now you can blow that off now with the impact after you've checked the back with the light to make sure that it's seated properly.
Yep, it's all flush.
Perfect. Take your impact and blow that off.
Cheers, Dave.
Dave, what you want to do is repeat this process 7 more times, doing exactly how you did it. You did it perfect.
Thanks.
Dave, if this was a vehicle that had not been touched and the studs were good and they weren't torqued over 230 foot-pounds, what you do is take a wire brush to the studs and clean them up. But because these are new studs, you don't have to put the oil on them. But we're going to put brake clean on them, which is going to strip most of this emollient off of there. So we're going to oil the fastener. But just make sure that there's no oil or residual oil on the back or on this hub surface there, the pilot surface. So go ahead and give it a quick rinse off and blow it dry and we'll be good to go. That's good. Dave, what we're going to do now is take a clean rag, or as clean as rag as we have, and we're going to put some 30 weight motor oil. That means that when I say 30 weight motor oil, does that mean Duralube, WD-40, any of those others, Transfluid, Rear End Dope? No, it means motor oil. What we're going to do with this motor oil is we're going to lubricate the first inch of this stud, and we're just going to go like this, making sure after it's lubricated like this not to get any oil on this piloted hub surface or this hub surface there. So go ahead and finish that up. Now what that does is when you put that first inch of oil on there, that's like taking this back up to original specs, where you'll get your 21,000 pounds, 20 to 21,000 pounds of clamp load.
Okay.
Good deal. It's time to put the wheel on. All right, Dave, here's the second wheel. This one's an aluminum wheel, and we cleaned up the hub surfaces as though it was a steel wheel. And what you want to make sure is that you align your valve stem so that you can get through this 10-hole aluminum wheel to the inside wheel to pressure up the tire. Dave, what you want to do now is take 30 weight motor oil. I can't emphasize this enough, that only 30 weight motor oil should be used. Any of the super lubricants can cause more clamp and you may injure the stud using the super lubricant. So only 30 weight motor oil. Doesn't matter if it's 20/50 or 30 weight, but it's got to be motor oil. So what we're going to do is put a drop of oil, or a little bit of oil, making sure that we don't get any oil on this surface or on the surface of the wheel. Spin it around. We're good to go. Repeat the process 7 more times. So Dave, turn your gun down a little bit. And what you don't want to do is surpass 165 and go to the 230 mark plus and hurt the stud already again. So go in the cross manner of tightening that, pull the wheel so that it's flat, and then we'll worry about torquing it after you get it sucked up. Dave, right now I want you to do that cross pattern again like you did, but now I want you to torque them to 165.
That's what I got it set at, so.
Perfect. Now, what kind of oil should I use on those?
30 weight oil, motor oil.
That's correct. Any WD-40, any Slick 50, any Duralube, any trans fluid, any rear end dope,
Nope,
any synthetic fluid.
nope.
That's it. 30 weight motor oil.
There you go.
How many pounds of clamp does that give you at 165 foot-pounds?
A whole lot of clamp.
20 to 21,000 pounds of clamp per stud. And what holds that wheel on there? Friction.
Okay, they're torqued at 165.
All right, Dave, just for good measure and so you can sleep at night, go once around the block. Make sure that you didn't miss any.
And that's the process for the wheel maintenance for the F550.
David, I'd like to thank you for being our tech today.
Not a problem.
Dale, thank you very much for your expertise. And Jerry, thank you also for your expertise.
You're welcome.